Entergy. Thousands of people working together to produce and deliver electricity for nearly 2 million customers throughout the Mid-South. Though virtually every aspect of operating a power company has become more complex, customer expectations have remained constant to receive reliable, friendly, quality service. To meet these expectations, Entergy made a commitment to continually search for ways to streamline its processes, reduce costs, increase productivity, and provide its employees with the tools they need to deliver the service that their customers deserve. In essence, to commit itself to total quality improvement. In 1990, Entergy began to research and develop a comprehensive, systematic approach by which to train quality action teams in the tools of team-based problem solving. How to understand the role of teams and team members. Define problem-solving opportunities. Apply process analysis techniques to determine the causes. Use problem-solving tools to decide on solutions. And to deliver recommendations to management. This video was produced to show how one team of Entergy employees used this method, known as the 4 Ds, to successfully resolve a process problem. In this segment, we'll see how a team actually begins the process by utilizing the first D, define the problem. We will see how a team recognizes a problem-solving opportunity, clearly defines what the problems are, what the desired outcome would be, and what tools are effective in focusing a team's efforts. In an effort to apply the concepts of total quality improvement, the Mississippi Power and Light lead team selected the management of dock time as a pilot project. MP&L determined that one problem-solving opportunity existed within its loading dock area. Upon review, it was the opinion of MP&L that the current state of the dock area was not as efficient as it could be, and that these inefficiencies consistently contributed to unnecessary delays in daily crew departures. To address the problem of excessive dock time, MP&L formed the Dock Time Quick Start Team. The team consisted of a cross-section of MP&L employees from related departments, which were close to the job itself: construction foremen, schedulers, storeroom personnel, engineers, and dock area supervisors. Entergy realized that if all were to benefit from problem solving, all should be involved right from the beginning. The first goal of the team was to define specifically what dock time actually was. The team then identified what the desired results of their efforts would be: to significantly reduce dock time, to improve the total efficiency of the dock area, to allow the crew to arrive at the job site faster, and to provide more time each day on the job sites. The team began to define the problem by brainstorming, or listing each of the concerns they had which they felt contributed to the overall problem. Then they combined concerns of a similar nature. Next, the team multi-voted and eliminated those items considered less important. The result was a list of 23 key issues, each of which had the potential for reductions in dock time. The team then established a baseline. In this case, the baseline would be defined as an accurate average measure of dock time, comprised of data obtained from different Entergy locations under varying conditions, such as weather, workload, and the number of service-related emergencies demanding response. By developing a list of probing questions based on the 23 key issues, the team was able to establish criteria to benchmark their process against other companies. Questions such as these helped the team to identify what made different locations similar or dissimilar, and how each aspect affected that location's dock time. From the data obtained, the team established that the baseline for all locations of MP&L's Central Division was 45 minutes. The team agreed that their mission was to develop recommendations which would reduce dock time by 1/3, from 45 minutes to 30 minutes. Realizing the need for more information, the team looked both within and outside of Entergy to review what system power companies and similar power companies outside of the Entergy system had done to analyze and reduce dock time. Members of the team were invited to visit AP&L, LP&L, Mississippi Power Company, and Alabama Power Company. From the information gathered, the team again multi-voted and reduced the 23 items to 10 key problem areas on which to focus their efforts. The first D, define the problem, showed us what is required to begin the problem-solving process. We saw how the team was assembled from different but related departments, brainstormed topics, multi-voted, collected internal data, benchmarked their performance against other companies, and created a mission statement. Your instructor will review these and other tools in detail and help to prepare you for our next segment, Determine the Causes. Now that we've seen how the team applied the first D, define the problem-solving opportunity, let's look at the second part of the 4 Ds, determine the causes. In this segment, we will see how the team collected additional information, used process analysis techniques to determine potential causes, isolated the most significant causes, and used tools of team-based problem solving. We last left the team when they had identified 10 specific process problems which affected dock time the most. At this time, the team realized that they needed to see in clear graphic representation the actual series of events which led to a construction crew leaving for a job. A flow chart was generated to help the team walk through each step in the process. The team then returned to the 10 main problem items and initiated further review and analysis into each. To help the team narrow their focus to those items which were the most important, Pareto diagrams were utilized. The theory of Pareto diagrams resides in the fact that in many business environments, it is 20% of the causes which result in 80% of the effects. The team was now faced with a unique, unexpected challenge.
Customer satisfaction is a very important part of total quality. In going over our flow chart from the beginning to the end of the cycle, we found that the crews were actually our customers, and it was our responsibility to make all the necessary improvements on our end of the table to enable the crews to get out as soon as possible.
Trend charts were then used to document the frequency of each occurrence outlined in the Pareto diagrams. Let's review what we've learned. In the second D, determine the causes, we saw how the team used flowcharts, Pareto diagrams, and trend charts. Your instructor will review each of these and other tools in detail and will prepare you for our next segment, Decide on Solutions. Now that we've seen how the team applied the second D, determine the causes, let's look at the third part of the 4 Ds, decide on solutions. In this segment, we will see how the team used problem-solving tools to develop and justify recommended solutions. We will see what types of tools are in the team's toolbox and some of the different types of solutions. When the team brainstormed possible solutions, criteria screening was utilized to isolate those solutions which would have the farthest reaching effects. The team now had 10 potential solutions to address. Now that the team had a listing of potential solutions, they generated a force field analysis to further study each of these solutions. Force field analysis can be thought of in terms of drivers and restrainers, or forces supporting progress toward the desired outcome versus forces preventing the attainment of the desired outcome. The team used the next tool of team-based problem solving, the contingency diagram. Contingencies, by definition, are those occurrences which happen by chance at uncertain and often unexpected frequency. These diagrams were highly useful in developing prevention plans to keep phone calls, unexpected visits, and other contingencies from interrupting the workflow during the crew's loading and departure procedure. Next, the team completed a cost-benefit analysis for each potential solution to illustrate how much a process improvement would actually cost and compare this figure to anticipated return on the investment. In the third D, Decide on Solutions, we saw how the team used criteria screening, used force field analysis, generated contingency diagrams and prevention plans, researched cost-benefit analysis. As you can see, there was a lot to do to decide on solutions. By using these tools in a systematic approach, the team was able to consistently and efficiently narrow the focus of their efforts to deliver recommendations which would yield the maximum possible dock time reductions. Your instructor will review each of these tools in detail and prepare you for the final segment, Deliver Recommendations. Now that we've seen how the team worked through the third step, Decide on Solutions, let's look at the last of the 4 Ds, Deliver Recommendations. We'll see how the team prepared their recommendations by creating action plans to document and articulate the results of their efforts, to analyze the actual customer requirements, define each problem area, state the conditions and events which contributed to each problem, define the gap between the present state and the desired state, define how they arrived at their solutions, recommend implementation sequences, define the personnel and material resources required, and propose measures by which to identify reductions in dock time and related company benefits. The team was now able to take all of the data accumulated and begin creating a well-thought-out, concise report to deliver to management. You'll recall that because the team continually refined and focused their efforts, they reduced what had originally been 23 individual recommendations to 10. By continually combining similar solutions, the team was able to reduce this list to 6. Let's take a look at each. Recommendation 1. Increase management presence on the docks. This would decrease unnecessary time spent in the yards by providing support for the crews with a ready resource to answer questions. Recommendation 2. Create AM/PM work policies. This would reduce time by helping to eliminate the confusion of crew members as to the timing of their activities. Further, this would reduce the difficulties associated with inconsistent expectations about crew members' duties, such as who is responsible for fueling vehicles, returning unused materials to the storeroom, and other duties. Recommendation 3. Hold engineering and construction scheduling meetings. This would reduce time by alerting construction crews to the jobs which are being prepared for, alert engineering of construction backlogs, and to reduce rush jobs. Recommendation 4. Pre-fill jobs and have material behind the vehicles in carts by 8:15 a.m. This would reduce time by eliminating the confusion associated with waiting on materials to be retrieved from the stores, too many employees involved in the material retrieval process, and delays in occasional materials substitution. Recommendation 5. Make dock time a performance measure for foremen. As the company benefits from reduced dock time, the team felt that foremen should be rewarded for exceptional performance in establishing the efficient use of dock time as a priority and seeing that dock time is kept to a minimum. Recommendation 6. Make scheduling a performance measure for foremen and engineers. This would further support the engineering and construction meeting in Recommendation 3, aid in creating weekly construction schedules that are attainable, and reflect a coordinated effort by both departments. We've now seen how the team worked its way through the 4 Ds. The team defined problems, determined the causes, decided on solutions, and now has delivered recommendations. We've also seen many of the tools and procedures useful to team-based problem solving: brainstorming, multi-voting, data collection, baselines, benchmarking, mission statements, flowcharts, Pareto diagrams, trend charts, criteria screening, force field analysis, contingency diagrams, prevention plans, cost-benefit analysis. The team delivered its dock time study to management in December of 1990. As a result of all 6 recommendations being implemented, by March of 1991, the average dock time of MP&L's Central Division was reduced from 45 minutes to 26 minutes, and the total net savings are estimated to be over $189,000 per year.
Entergy Corporation's definition of quality is improving every day in the eyes of the customer. The only way this can be accomplished is with the active involvement of employees at every level in problem solving. The efforts of the dock time team reflect this basic quality attitude in its purest sense.